So today we're going to take a look at day 2, another day of solving. So make sure if you missed day 1 that you're getting caught up from that. So we are going to take a look at a review of a couple from yesterday. So let's make this a little bit larger here. Alright, so from yesterday we solved some where the sine of theta equals 1/2. So we're looking for that angle. And we know sine is y. So when it's positive, so here would be positive half. We know opposite half is 30. So we'd have 30 degrees over here and 150. But it says have it in radians. Well, we know 30 degrees is pi over 6. And this is 5 times 30, so we have 5 pi over 6. And now this next one here, we have our cosine is the square root of 3 over 2. So cosine is x, and it's positive. So here we'd have square root of 3 over 2. But there's also down here, that's x as well. So this would be 60, 30. So we have 30 degrees and 330 degrees. So again, that this is pi over 6. 11 times 30, so we have 11 pi over 6. So now what we're going to do is we're going to take a look at some that are a little bit more complicated. So going back to something from last semester, solving this. When we look at this one, we can factor out a 4x from both. So this becomes 4x, x minus 2 equals 0. So either 4x equals 0 or x minus 2 equals 0. So x equals 0 or x equals 2. In this one we have a variety of options. We could factor it, we could do the quadratic formula, any one of these. So if we were to factor, this would be x minus 3 and x minus 2 equals 0. So we have x equals 3 and x equals 2. So now we're going to use some of those ideas of factoring when we look at some trig equations. So let's take a look at this next one here. Well, we have sine and cosine, but one thing I noticed, there's a cosine in both. So this is really the cosine of x. If we factor that out, we'd have the sine of x minus half equals 0. So either the cosine of x equals 0 or the sine of x minus half equals 0, which would mean the sine of x equals half. So where is our x value 0? Well, that would be here and here. So we have 90 and 270. But in terms of radians, so pi over 2, 3 pi over 2. And then we have the sine of x being half. Well, I believe that's one we did. So sine is our y value. So we have 30, opposite is 30. So we have 30 degrees and 150 degrees. But again, 30 degrees, so we have pi over 6, 5 times 30, and 5 pi over 6. Now this next one here, we don't have to factor anything, so this one either the sine of x equals 0 or the tangent of x minus 1 equals 0. Well, this would mean the tangent of x equals 1. Well, sine, we know sine is our y value, so here and here, because this is 1, 0, negative 1, 0. So I know that this is pi, and over here we could call that either 0 or 2 pi. And then where does the tangent equal 1? Well, that means our y over x, the opposite over adjacent, have to be the same. So that's got to be 45 triangles. And then I got to figure out, well, which quadrants? Well, this would be a positive and a positive. So it has to be this one. This would be a negative and a positive, so it's not that one. A negative and a negative, so it has to be this one, which would be 225. And this is a positive and a negative, so it can't be that one. So I know 45 degrees, so this is pi over 4. And then this one, let's see, 1, 2, 3, 4, 5 pi over 4. Because this is 5 times 45. Now let's take a look at this next one here. So we have to do some solving. So we add 1 tan squared of x equals 3, divide by 3. So we have the tangent squared of x equals 3. Take the square root. So where does the tangent equal plus or minus square root of 3? So this is either 30, 60, 90 or 40. Well, it's a 30, 60, 90. It's not a 45, 45. So where does our y over x equal square root of 3? So let's see. If I was to make this a 30 triangle, half root 3 over 2, so y over x, that's 1 over root 3, so it's not that one. So that means it has to be our 60s. And it's plus or minus, so it could be all of our 60-degree reference angles. So we have 60 degrees, 120, 240, and 300. So this is 2 times 60, 4 times 60, 5 times 60. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now let's flip to the back page here. Well, let's see this one. Well, we can't factor it, and I have a sine and cosine. So it's because we have that sine squared and cosine squared there. So what we're going to do here is we're going to take a look at something called the Pythagorean identity. So we know the Pythagorean theorem, a squared plus b squared equals c squared. So when we look at this, if we have an xy triangle in 1, we know x squared plus y squared equals 1 squared. Well, what do we know our cosine of theta is? X over 1 is x. So our cosine of theta equals x. Sine of theta, opposite over hypotenuse, is y. So the sine of theta equals y. So really, cosine squared of theta plus sine squared of theta, oops, I should put theta there, equals 1. And this is like a squared plus b squared equals c squared, but it's known as our Pythagorean identity there. And now we can get a couple other ones here. If we divide this by the sine squared, we end up with 1 plus cosine over sine is the cotangent squared. 1 over the sine is the cosecant squared. So that's another identity. And if we divide by the cosine squared, sine over cosine, opposite over adjacent, that's our tangent squared of theta, plus 1 equals 1 over the cosine is the secant squared. So we have all these identities. And then it's important to know we can move them around too. For example, if we wanted to solve for cosine squared, I could subtract it, and I could say sine squared of theta equals 1 minus the cosine squared. Or I could say the cosine squared of theta equals 1 minus the sine squared. So what we're going to do now is we're going to go back and we're going to try problem 6. So we have all this sine and cosine business. So I have 2 cosines. So I'm going to use that identity, and I'm going to solve for the sine squared. So I know that would be 1 minus the cosine squared of theta. So if I replace this with 1 minus the cosine squared of theta, cosine squared of theta, I'm going to switch those to thetas, and solve this, so plus cosine squared of theta minus 1. So now I have 2 cosine squared of theta minus the cosine of theta equals 1, or excuse me, equals 0. And I could factor out a cosine, so cosine of theta equals, I am just messing this up left and right here. So factor out a cosine, so we'd have 2 cosine of theta minus 1. So for this one here, let's see, either the cosine of theta equals 0 or 2 cosine theta minus 1 equals 0. Well, add 1 here, divide by 2. So either the cosine of theta equals half. So where is cosine or our x value 0? Well, here and here. So 90 degrees and 270. So we have pi over 2 and 3 pi over 2. And then where is it half? So if that's half, 30, so this would be 60 degrees. So we have 60 degrees and 300. So we have pi over 3 and 5 pi over 3.